Okay, so in the last video we set up some of the algorithm. Now we're setting up the rest of it. So we're up until here, this delete one of Q, and then showed you running it where we've got that there. Just watch it again, we can step through it. And if we watch this, it shows all that being done, and then we did see it quickly flash so that A was here. I'll run that again, A being at the top here, and then it disappears and ends up over there. That's what we ended up with there. If you're wondering why A stays there, it's because if you guys are still there, the program, whenever we run these programs, it doesn't reinitialize everything to 0. Okay, so let's hide these two things. Go. All right, let's have a look at the rest of the algorithm. So what we're doing now, we need a while loop, so and that appears in this way. So we're going to repeat until this. So while u is not equal to the end, or repeat until this is the case. So we're going to take our control. We're going to say we're going to find repeat until, and repeat this until. I'm going to drag our equals, repeat until start node equals end node. So let's take start node is equal, I hate when that happens, start node is equal to end node. So that's what it's going to do. Oh no, so not start node, u. So this node, the node in u, so I'm going to put that in there. Alright, let's get rid of that. So we're going to repeat that. So now we need a for loop. So we're saying for v of neighbors of u. So what we're doing, now we're looking for the neighbors of a. A is set to u, as we saw before. Let's bring that up again. A is set to u. So we're going to say, we're going to use a for loop. So we're going to say for each item of, we're going to go to nodes. We're going to say neighbors of. We're going to drag u. So I'm just going to duplicate that and put it in there. Okay, drag that back. Okay, for each item, so what we can call this something else. For every node, for each node of neighbors of u. So if we look at u, in this case A, our two neighbors are E and B. So that's what's going to happen. So what we're going to do with that, we're going to set the alt. So we're going to set the alternative thing to the distance of node u. So whatever our initial distance is, we're going to set that to the label of that edge u plus v, u to v. So u to v. Oh, so we're not v. We're going to use node. So we're going to say set alt. We might be able to call this temp. Set alt to the distance of node u. The distance. So we need node. We need distance of node u duplicate. We're doing the addition here. We're going to have to have them together. So we need a plus. Distance of node u plus distance of node u plus label of that edge. Label. So we're going to go to edges. I'm going to say label of the edge between the node that we're working with. I'll just drag that in. Edge, we need edge as well. Edge between the node we're working with and u. And I'm going to put that in there. So we're just storing this somewhere. And then what we're going to do is now we're going to check that. We're going to say in the next line, if alt is less than the distance of v, so that is the next node. So what we're doing is we're saying, okay, whatever we've got, we're going to change this to distance. So what we're doing, we're taking the distance of node u, in this case is a, which is 0, and we are adding that to each of these. So we're adding it to 1 and to 8. Okay, and then what we're doing is we are setting, now we're going to say if, And now we'll put that inside the for. Set, underneath set we put our if statement. So we're saying if, we may need another video. Do we need anything else? Or just if? Just if. So if alt operators, we need a listing. If the variable alt is less than the distance of node v, node distance of node v, and in this case we've called it node. Let's just drag that in. If that's the case, we're going to set the distance of node v to alt. So we're going to set, set the distance of node to alt. And duplicate that. Okay, so what this is saying here is that for each neighbor of u, it's going to set alt, so it's going to take this temporary variable, alt, and it's going to set that to the distance of node u, so whatever the node's distance is, whatever is beside, plus the label of the edge, so that is this here, okay? And then what it's doing is checking if alt, so if the distance, so if the distance of the node plus the distance of the neighbor is less than the distance of the node, then distance of the node, then what it's going to do is going to set the distance of the node to whatever that is. So right now, has a distance of infinity, B has a distance of infinity, A has a distance of 0. So what's going to happen is we've got a label here of 1, we've got a label here of 8. So what it's doing, it's checking there's something called alt. So it's saying alt is going to store 0 plus 1 for E, and it's saying, then it does the check, is alt less than the distance, less than infinity? Yes, it is. Well, we're going to set the distance of that node to 1. It's doing the same thing over here for B, saying 0 plus 8, it's setting alt, our variable called alt, it's setting it to 8, and then after that, what it's doing, it's saying, it's using this, is 8 less than infinity? Yes, it is. Then it's setting the distance of this node, the node attribute, to to 8, and that's what it does there. And it does that for every node. So it'll do that. So it'll do that. Then once it finishes that, then it goes on to the last part of the algorithm, and we're going to put that in another video.